This video was brought to you by Indently.io, learning Python made simple. How's it going, everyone? In today's video, we're going to be covering 10 Python concepts that you should know about. So starting with the first concept. After you have downloaded Python from python.org or wherever you downloaded it from, you can create a file anywhere on your computer using the .py extension. For example, if we want to create our main script, we'll just type in main as the name and add the .py extension. This will make it a Py file or a Python file, which will be executed by an interpreter. In Python, if you want to create a variable, you start by typing the variable name, followed by an equal sign and the value that you want to assign to that name. For example, here we can type in Bob, and Bob might have an age, so we can create another variable called age, and that's going to be 20. Now, if we ever want to use these, we can just refer to those variable names instead of hard coding in the values or typing them in by hand each time we want to use them. For example, using the print statement, we can print the name, comma, age. If I can spell that, I still can't spell that, age. And when we run it in the console, you should see that we were able to use both of those variables, which again is quite convenient because we can use these anywhere in the program. I mean, another example would be, hello, my name is, and then insert name. And we would get that as an output. In Python, we have many data types, and the basic data types are integers, floats, strings, booleans, which can either be set to true or false. Then we have lists, tuples, sets, and dictionaries. An integer is any whole number, while a float is any decimal number. A string is anything that's inside quotes, and that can be either single quotes or double quotes, and it just represents text. While a boolean is used to represent two states, either true or false. Then we have lists, which can contain an arbitrary amount of elements. So in case you have a grocery list or a list of names, we have a way of handling that kind of data. After we have tuples, which are a lot like lists, except they are immutable, which means once you set the data, you can't add anything to it or remove anything from it. While with lists, you can perform many operations, such as adding elements and removing elements. After that, we have sets, which are quite similar to lists, except here you cannot have any duplicates. Everything is guaranteed to be unique. And finally, we have dictionaries, which is the basic way of representing key and value pairs. So here we have a name of Bob and an age of 20. In Python, we have the option to use type annotations. Type annotations are completely optional. And to show you what type annotations look like, let's create a simple example, such as name is equal to Bob. This is obviously a string, but we can also tell Python explicitly that this was meant to be a string by annotating it with the string type. And we can do the same thing for the age. We'll say age of type integer is equal to 11. But what you will notice is that if we insert something wrong, our code editor is going to give us a warning that we did not pass in the right type. And when your code gets more and more complex, these warnings become a lifesaver. Because as programmers, we are bound to make mistakes eventually, whether it's because we are drunk, tired, or just not that attentive, we're bound to make a mistake eventually. And having these warnings help a lot, because if we did not specify this to be of type integer, we would not get any warnings there. The code editor would not know what we were trying to do, so we would be able to do that, even if it's not what we wanted. Although it's important to point out that even if we defined this to be of type integer and we assigned it a string, the program is still going to run as normal. Type annotations do nothing in terms of how the program executes. They are just a tool for the developer. And my favorite analogy for using type annotations is the traffic light. If you think about it, when you're driving, a traffic light doesn't really do anything. It just has 3 colors that tell you when it's safe to drive through an intersection. It doesn't do anything at all. You can still drive through that intersection even if the lights are red. Sometimes that might go well, and other times you might end up in an accident. So type annotations are kind of like the same thing. They do not prevent you from making terrible mistakes, but they warn you that you're about to make a mistake. Moving on, constants. In Python, we don't really have any way of creating constants, but you can use type annotations along with the caps lock naming convention to show that it is a constant. For example, if we were to import from typing the final type, we can now tell Python using type annotations that we are creating a constant. For example, we might have a version number of type final of type string, and that's going to equal 1.0.12. And that would be the correct way to define a constant. Even without the type annotation, you will know it's a constant by the use of uppercase characters. But unfortunately, we can still change the constant. So we can say that the version is now 1.1. And your code editor will give you a warning only if you're using the final type, because this type annotation explicitly tells the developer that this value or this variable should not be overwritten. So here we're going to get that warning. But otherwise, you can even have a constant such as pi, which will be of type final of float, and that can be 3.1415. And that's another example of how you could create a constant in Python. Next, we're going to be looking at how we can create reusable code in Python. So to get started, I'm going to import from datetime the date and time. And what we want to do with this is show the user the current date and time. So we're going to print, this is the current time, and we're going to print the datetime.now. When we run this, we're going to get the following output. This is the current time with the current date and time. So that works perfectly fine, but if we ever want to reuse this, we're going to have to copy and paste this everywhere, which is a terrible idea because one day you might decide, what if I wanted to type in this is the current time and date, or date and time? Well, that's perfectly fine. We updated it where we had to. But the problem is it did not update in the other places, which sucks because now we need to manually waste our time going through our project, which could be thousands of lines long, to fix all the occurrences. So this is where functions come in. And in Python, to create a function, we use the def keyword. So here we can type in show date, and this is going to return none. And then all we need to do is indent this code inside the function. Since Python uses significant indentation for its code blocks. But now, thanks to that, we can just type in show date and duplicate that. And no matter how many times we use this function, it's always going to come from the same source, which means now we can type in this is the current date and remove the last bit, and it will update everywhere we use this function. Otherwise, if you want to make a function more customizable, you can provide parameters. And to do so, we can create another function called greet that takes a parameter called name. And that will be of type string. And once again, this will return none. And inside here, we can print the f string of hello name, so that the next time we want to use this function, we can say greet Bob, duplicate that, and greet Luigi. And that will greet both of them using the parameter that we have specified, which is really nice because once again, if we ever need to apply any changes, we can do so here. We can say ciao instead of hello. And the next time we run this, we will get two outputs with that update. And functions can even return results. For example, we might have a function called add that takes a of type float and b of type float because we want to add these two numbers together. And the intention with this is to return a float. Well, to do so, you just need to return that data type, so a plus b. And now if we were to print, let's say, add 1 and 2, this function would return a result, which means calling this function will give us back the result of 3. And it's actually optional to define a return type. It just, once again, makes our code much more safe, because if for whatever reason we return the string of hello, our code editor is going to complain that hello was the wrong type. And if your function doesn't return anything, for example, if you're just printing hello, you can explicitly say that you are returning none, which just tells the developer that this function was only meant to be run and that they should not expect a return value from it. Moving on, we have the concept of classes. And to break down what a class is just a blueprint for code. But let's get started by creating the main components of a class to see how it works. And in Python, to define a class, we use the class keyword followed by a name starting with an uppercase character. And this is how you would create a class. Now, obviously, it would be much more useful if this class could do something, because all we did is insert an ellipses as a placeholder. So what we're going to do instead of that is define an initializer. And an initializer is used to set up an instance of the class, which means we're going to create an object from this class using some specific information. And the specific information we want to use for each one of these cars in this class is what color the car should be, which will be of type string, and how much horsepower that car has, which will be of type integer. And initializers return none by default, and they will always return none. But personally, I love to specify that. Now, inside the initializer, we need to assign these values to the instance of the car. And to do so, we need to use the self keyword. So self.caller is going to equal caller, and self.horsepower is going to equal horsepower. Now, with that being done, we can create a car called Volvo, which will be of type car, and the car is going to be a red car with 200 horsepower. So this part here is what we refer to as an instance of the class, or an object of the class, because we are instantiating it with this specific information so that we can have a customized object. And what that means is that we can type in Volvo and refer to the caller, or it would be more fitting to print that, and also the horsepower. We can refer to those attributes which are related to the instance, so that when we run this, we will get that information back. As you could see, the class was just the blueprint for how that car should look. And with that blueprint, we can create several cars, and it just simplifies that process. So instead of having a Volvo, or in addition, we could also have another car called BMW, which would be blue, and it would have the horsepower of 240. Now we could print BMW with the caller and horsepower, and we would get the output for the BMW as well. So classes simplify the process of creating objects, or code that has to be duplicated a lot, because otherwise it would be quite difficult to create many different cars that all share the same attributes or the same properties. But I'm going to remove all of this, because what we're going to do next is learn about methods. And instead of caller, I'm going to change this to brand. And the brand for Volvo is obviously going to be Volvo. Anyway, with this, we can actually go down inside our class and define a function. And a method is just a function that's inside a class. Anyway, here we're going to create a method called drive, and that's going to return none, because what we're going to do is print that the self.brand is driving. And what's important to note here is that we have self written everywhere, and self refers to the instance of the class. So here we have a Volvo, and we are referring to its attributes. So in other words, self is the Volvo. And if we had a BMW, self would be the BMW. It refers to the instance. So if you actually want to refer to these values, you're going to have to use the self keyword. But we'll create one more method called getInfo. And that's going to return none, because we're going to print self.brand with self.horsepower, horsepower. And that's going to be our entire class. Now we have a class with some attributes and some methods. So with that, we can type in Volvo.drive and Volvo.getInfo. These are methods that we can use on that instance. And when we run that, we're going to see that the Volvo is driving and that it's a Volvo with 200 horsepower. And this can be used with any object of this class. So if we were to have a BMW, once again, which will be of type car, and that was to be BMW with the 240 horsepower, we can now drive that BMW. As you can see, the BMW is driving. And also you're not limited to just using the information inside the class, but you can also define your own parameters in methods. So after the self keyword, anything you type in is going to be a normal parameter. And I'm just going to call this variable of type integer, just as an example, to show you that we can now use that. And to refer to it, you do not use the self keyword, because this is included inside the method signature. So now the next time we actually use getInfo, we're going to have to also give it a value. And I'm going to remove the BMW and run this. So as you can see now, we have 10 and Volvo with 200 horsepower. We were able to use this information inside the method just by including it as a parameter. But let's remove all of that, because the final concept I want to talk about in this video is the concept of dunder methods. And we're still going to have our Volvo car for this. But right now I want to show you that if we were to print Volvo as it is, what we're going to get back is a car object, which is located at this memory address. And that information isn't that useful to anyone who's not a programmer. What if we actually want to get back the information that's inside the car? Well, we can do so using a dunder method. And a dunder method is just a double underscore method. So here we're going to define the string dunder method. And this is going to return a string. So what we're going to do is return the f string of self.brand and self.horsepower, HP. Now, the next time we try to print this Volvo, what you're going to notice is that we're not going to get that complex object back, but we're actually going to get the string that we specified. Because now in any situation we refer to it as a string, it's going to use the string dunder method. And another example of a dunder method would be if we wanted to add cars together. We could use the add dunder method. So this is going to take self and other, which is going to be the object that we want to add to the current object. And for this example, we're just going to return a string. Why not? So what we're going to do is return the f string of self.brand and other.brand. And if you actually want your code editor to give you suggestions for this, you would have to annotate this as self, which can be imported from the typing module. So from typing, import self, other of type self, and that will lead you to this code completion, which contains brand and horsepower. Anyway, to make this work, we're going to have to create another car called BMW of type car, which will equal a car called BMW with 240 horsepower. Next, we can print Volvo plus BMW. And this dunder method is going to take care of the functionality of plus, which means that when we run this, we're going to get Volvo and BMW as an output. Without this dunder method, Python's not going to know how to handle this because it does not define the add dunder method, and it actually warns you about that. But if we were to run it anyway, once again, it would not know how to do that. So you can choose to define that in your class and then it will work properly. And it's worth mentioning that there are a lot of dunder methods worth researching. Because obviously, maybe in the future, you will want to multiply cars. So for all of these operations, there's a dunder method for them, such as multiply. And once you define that, you'll be able to use this comfortably. But yeah, those were 10 Python concepts that are quite important. And this video was just an introduction to them. I still recommend you study these concepts more thoroughly, do some more research online, watch some other YouTube videos regarding them, but otherwise it should have been a great starting point for how the concepts in Python actually work. So yeah, let me know in the comment section down below whether you have any other questions or whether some concepts should have had some more explanation. But otherwise, with all that being said, as always, thanks for watching and I'll see you in the next video.